Hello everyone and welcome back to this series of videos on the Solow growth model. Specifically in this video, we are going to focus on seeing how the Cobb-Douglas production function satisfies one of the main assumptions of the Solow growth model production function itself, which is that it needs to have positive marginal product of each factor input. Let's look at it mathematically and in general terms. Our production function takes the form of k to the power of alpha, L to the power of 1 minus alpha, and specifically note that here we are assuming that total factor productivity is equal to 1, and that we haven't properly defined these alpha yet. This is the capital share of income, while 1 minus alpha is the labor share of income, and we're going to define them in more detail in a future video. So how to calculate the marginal product of capital? We need to take the partial derivative of output with respect to K. Why is that the case? Because the marginal product of capital and the marginal product of labor, they refer to how much output changes following a change in the factor input. So for example, changing capital, keeping the other factor constant. So in this case, for example, we are going to differentiate the production function, Cobb-Douglas production function, with respect to K, and we're going to treat L as if it was a number, as if it was a constant. And so we don't need to worry about it too much for the time being when we differentiate with respect to capital. So we are going to follow the chain rule and take the power of the alpha down multiplied by k to the power of alpha minus 1, as we also need to subtract one of the exponents, and then multiply all of this times L to the power of 1 minus alpha. As we said, we are treating it as a constant. And notice that this is going to be greater than 0 because our alpha is going to be included between 0 and 1. So it's always going to be positive. Hence, we have a positive term. K to the power of alpha minus 1 is going to be 1 over k to the power of 1 minus alpha, which is positive again. And we know that we need to have positive factor inputs in order to have some outputs. Because imagine if we had k equals to 0, then there would be no output at all, because we would multiply L by 0. Hence, we would get 0 here as well. As we know that both K and L have to be positive, which result in having a positive marginal product of capital. We can do the same thing for labor, for the marginal product of labor, so we can differentiate with respect to L, keeping K constant. So we're going to follow the chain rule again, and we're going to write down 1 minus alpha, so we're taking down the exponent here, subtracting 1 from the exponent. So we're going to have k to the power of alpha that stays as constant, and then L to the power of minus alpha as the two ones cancel out. And again, we're going to have a positive term because 1 minus alpha is going to be positive, as we've said already that alpha is included between 0 and 1, and capital and labor are going to be positive again. So mathematically speaking, both the marginal product of capital and the marginal product of labor are positive, meaning that if we add capital or labor, output is going to increase. And if we take away capital or labor, output is going to decrease. We can look at this also with a couple of practical examples. So let's assume that this alpha is equal to 0.3, and let's look at what happens to output if capital used in the production were to be increased by 10%. To calculate this change in capital, let's make a ratio between new capital and old capital. And specifically, this would look like, recalling that our production function is something like this, we're going to add 10% to our capital. So we're going to add a change to our capital here, L to the power of 1 minus alpha, over our original output amount. And it's going to look like Well, let's remember that this change in capital is equal to plus 0.1. So it's as if we're adding 0.1 to 1. Hence, all of this is going to look like 1.1k. So if we rewrite 1.1k to the power of alpha times L to the power of 1 minus alpha over the original production function, then we can simplify very easily the L, and following the laws of indices, since we have the same exponent here, we can write everything within the same parenthesis to the power of alpha and cancel out the k, so that we are left off with 1.1 to the power of alpha, which is 0.3 according to our exercise assumption. And we're going to get something like 1.03, which is greater than 1, which means that the numerator of our fraction is going to be greater than the denominator of our fraction, meaning that output actually increased following an increase in capital. And it makes sense. Our marginal product of capital is proved to be positive. Let's now look what would happen to output if labor used in production were to be decreased by 20%. So we're going to follow the same reasoning that we followed before, and we're going to write the same fraction that we did before. However, this time we're going to not change capital, but we're going to add a little change to labor. And the same steps apply. This here is going to be, this time, since we are talking about a decrease by 20%, L minus, because it's going to be a negative change, 0.2 L. So that in total, 1 minus 0.2 is going to be 0.8 L. And we can already see that we can cancel out K. So we are left with 0.8 L over L, everything to the power of 1 minus alpha. And again, we can simplify the L out and write 0.8 to the power of 1 minus alpha, which is going to be to the power of 0.7. And the result is approximately 0.86, which is less than 1. So the ratio is lower than 1, meaning that the new output is going to be lower than the old output, meaning that since we decreased labor by 20%, output has decreased as well. So we can conclude by saying that there is a positive relationship between each factor input and output. Meaning that both the marginal product of capital and the marginal product of labor are going to be greater than 0. So if labor increases or decreases, output is going to increase or decrease, depending on which direction the two factors of production take.